In the Grand Archives of the German Wehrmacht, specifically within the bureaucratic paperwork of 1943, there sits a captured equipment assessment that history has proven to be spectacularly wrong. The document, circulated among division commanders, analyzed the tactical utility of British vehicles seized during the early campaigns of the war. When the evaluators reached the entry for the British Universal Carrier, known affectionately to the Commonwealth troops as the Bren Carrier, their dismissal was absolute. The German report described a small, tracked carrier with limited armor and asserted that it possessed no tactical significance. The official recommendation was ruthless: immediate conversion to utility roles or relegation to scrap recovery. This was the verdict of the purported masters of mechanized warfare regarding a machine they viewed as an oddity, a toy tank incapable of standing toe-to-toe with the heavy armor of the Third Reich. Yet, the irony of this assessment is devastating. 3 years later, those very same German commanders, who had read the report, were facing these insignificant vehicles at every turn, from the sands of Tobruk and the mountains of Monte Cassino to the hedgerows of Normandy and the bridge at Arnhem. The contradiction between the German assessment and the reality of the battlefield is one of the great ironies of World War II. While the German High Command was dismissing the vehicle on paper, their own soldiers on the ground were scrambling to capture and use them. By 1945, Germany itself was fielding captured Bren Carriers, modified with their own weaponry, fighting desperately alongside Wehrmacht units. The vehicle they had recommended for scrap had become so valuable that German engineers, driven by necessity, created at least 6 specialized conversion variants. They called it the Bren 731E, utilizing their Butapanzer code for captured English equipment. This disconnect highlights a fundamental misunderstanding of the British engineering philosophy. The British Army, facing a desperate shortage of resources and a terrifyingly fast enemy, did not try to build a perfect vehicle. Instead, they built a ubiquitous one. While soldiers from 30 nations praised its reliability, the statistic that truly matters is production: 113,000 units. This figure makes the Universal Carrier the most produced armored fighting vehicle in the history of warfare, a testament to the idea that quantity, when combined with mechanical reliability, possesses a quality all its own. To understand why this small, open-topped box on tracks became the backbone of the British infantry, one must understand the crisis of 1939. Britain's problem was not a lack of firepower. The infantry battalions were equipped with the superb Bren gun, the Boy's anti-tank rifle, which could penetrate early war armor, and highly effective 2-inch mortar. The problem was mobility. A soldier on foot moves at roughly 3 miles per hour, while the German mechanized infantry that tore through Poland and France moved at 30 miles per hour. By the time British infantry could march to a defensive position, they were often already flanked or overrun. The French army learned this lesson in blood during May 1940, as German armor punched through the Ardennes, while French units were still plodding toward their assembly areas. Speed was no longer a luxury. It was the primary determinant of survival. Commanders needed a vehicle that could keep pace with advancing armor, rush machine gun teams to key defensive points, and evacuate the wounded under fire. Trucks were insufficient as they bogged down off-road and offered no protection, while tanks were too expensive and spatially limited to act as infantry taxis. The British solution diverged sharply from their allies and enemies. Germany developed the SDKFC 251, and America, the M3 half-track, both of which were designed to carry a full squad of 12 men and offered reasonable armor protection. However, these half-tracks were complex and expensive. The German vehicle utilized a sophisticated, interleaved road wheel suspension that was over-engined and prone to freezing solid in the mud of the Eastern Front. The Americans prioritized road speed over cross-country performance. Britain, conversely, decided not to carry the squad, but to carry the squad's weapons. Instead of protecting 12 men, they designed a vehicle to protect 3 or 4 specialists operating the heavy firepower. Instead of matching tank armor, they used just enough steel to stop rifle bullets. Most critically, instead of custom military components, they utilized commercial Ford truck parts. The result was a vehicle that looked wrong to the traditional military ILO compact, and barely armored, but one that could be produced in numbers that the Axis powers could never hope to match. The engineering lineage of the Carrier traces back to Major Gifford Lacane Martel, a royal engineer obsessed with the concept of small, cheap, armored vehicles. In 1925, he built a one-man tankette in his garage, using a motorcycle engine and wood, arguing that future warfare required mobile protection that didn't break the national treasury. This concept was refined by the partnership of Sir John Valentine Carden and Vivian Graham Lloyd. Carden was a self-educated engineering genius with an intuitive grasp of suspension systems, while Lloyd was the salesman who could pitch these concepts to the military bureaucracy. Their Mark VI design caught the world's attention, achieving 25 miles per hour and carrying 2 men. When Vickers Armstrongs acquired Carden Lloyd in 1928, the resources became available to perfect the design. By 1934, the Vickers D50 had established the template: a Ford V8 engine in the center, a driver and gunner in the front, and an open cargo area in the back. The genius was not in the sophistication, but but in the ruthless standardization. The chassis utilized a Ford flathead V8, displacing 239 cubic inches, producing 85 horsepower at 3,500 RPM. It used a standard 4-speed manual transmission and commercial truck parts that could be serviced by any mechanic from London to Auckland. The stark difference in industrial philosophy is best illustrated by the numbers. Germany produced approximately 15,252 SDKFZ 251 half-tracks during the entire war. In contrast, Britain, Canada, Australia, and the United States combined to produce 113,000 universal carriers. This meant that while German panzer divisions were chronically short of armored transporter force, most of their infantry to ride in soft-skinned trucks or march, every British and Commonwealth infantry battalion possessed a full carrier platoon. The German Stuka half-track was 19 feet long and weighed 8.5 tons. The universal carrier was only 12 feet 4 inches long and weighed just under 4 tons. Yet the British vehicle had a ground pressure of only 7.4 pounds per square inch, allowing it to float over mud and soft ground that would swallow heavier machines. This cross-country mobility was the carrier's ace card. It wasn't designed to fight like a tank. It was designed to deliver firepower to where the fighting was hardest, drop off the weapon crews, and then act as a supply lifeline. The combat debut of the carrier in May 1940 during the invasion of France and the Low Countries revealed both its utility and its vulnerability. During the desperate siege of Calais in late May, Brigadier Claude Nicholson ordered a counterattack using the 1st Battalion Rifle Brigade's carriers against the 10th Panzer Division. The carriers, utilizing their speed, engaged German infantry in vicious street fighting, inflicting casualties and causing confusion. However, without heavy armor or anti-tank weapons, they could not halt the German advance. When Calais fell, and subsequently during the evacuation at Dunkirk, the British Expeditionary Force was forced to abandon nearly all their heavy equipment. This included hundreds of Bren carriers. The Wehrmacht, ignoring their own internal reports that dismissed the vehicle, immediately pressed these captured units into service. They designated them the Gepanzerter Maschinengewehrtrag Bren 731E. German workshops, desperate for mobile platforms, began mounting 3.7 cm Pak 36 anti-tank guns and 2 cm Flak 38 anti-aircraft guns on the chassis. In a twist of fate, the German army became one of the most enthusiastic users of the vehicle they had officially derided. The war in North Africa provided the perfect theater for the carrier's specific talents. The open desert rewarded speed and low visibility. Operation Compass, the British offensive in December 1940, saw Indian and Australian divisions using carriers to devastating effect. At the Battle of Bardia, Australian carrier platoons acted as a rapid reaction force. As infantry pinned down Italian defenders, carriers would race through the dust, flanking the enemy positions and suppressing them with Bren gunfire. The ability to move machine guns rapidly across the battlefield paralyzed Italian defenses that were static and prepared for a slower World War I style of engagement. The most legendary exploit occurred in February 19, involving Force, a flying column that raced 150 miles across the desert to cut off the retreating Italian 10th Army. The carriers of the Rifle Brigade established a blocking position at Bietefam for 2 days. These small vehicles, holed down in the sand, held off 20,000 desperate Italians and their armor. The carriers constantly repositioned, firing from one angle and then scuttling away to another before Italian artillery could zero in. It was a masterclass in mobile defense, proving that a thin skin is no liability if the target is fast enough to avoid being hit. As the war moved to the rugged terrain of Italy, the carrier's role evolved again. The mountains and mud of the Italian campaign neutralized the speed advantage, but highlighted the vehicle's climbing ability. At the Battle of Monte Cassino and during the breakout from Anzio, carriers became the lifeline of the infantry. When the 2nd Battalion, Sherwood Foresters, were cut off and pounded by German artillery at Campoleone, their survival depended entirely on the carrier platoon. These vehicles ran a gauntlet of shellfire to bring up ammunition and carry back the wounded. The open-topped design, usually a liability, made loading stretchers easier. The grim reality of the carrier crews in Italy was one of high casualties. Drivers were exposed to airburst artillery and sniper fire. Yet, the simple mechanical nature of the vehicle meant that even after taking damage, carriers could often be repaired in the field. A thrown track could be fixed in an hour. A Ford V8 engine could be swapped out in a day. This resilience meant that while German equipment's strength dwindled due to complex maintenance requirements, British units almost always had their carriers ready to roll. By the time of the Normandy landings in June 1944, the universal carrier had become a Swiss Army knife of warfare. On D-Day, carriers drove off landing craft and waded through the surf onto Sword and Juno beaches. In the bocage country that followed a nightmare landscape of high hedgerows and sunken lanes, the carrier proved superior to tanks and maneuverability. The 15th Scottish Division, fighting in Operation Blue Coat, used carriers to navigate the narrow lanes that trapped larger vehicles. Here, specialized variants proved their worth. The Wasp variant, fitted with a flamethrower capable of projecting fire 80 to 100 yards, was a terrifying weapon against German infantry dug into the thick hedges. At close range, there was no answer to the Wasp. German defenders either retreated or were burned out. The psychological impact of a small, fast vehicle appearing from a flank and unleashing liquid fire cannot be overstated. Simultaneously, the Canadians were using carriers to support their Firefly tanks, creating combined arms teams where the carriers protected the tanks from infantry infiltration while the tanks dealt with German armor. The sheer scale of production allowed for a saturation of equipment that the Axis could not comprehend. While German factories struggled to produce a few thousand half-tracks, the Commonwealth production machine was relentless. Canada alone built nearly 30,000 carriers. The Ford Motor Company of Canada expanded its plant specifically for this purpose, supplying vehicles not just to Canadian troops but to the Soviets, the Free French, and the Chinese. The United States produced 13,000 of the T-16 variant, and Australia built 5,600 with local modifications for jungle warfare. This global supply chain meant that a carrier destroyed in Normandy could be replaced almost immediately from a reserve depot. It was a triumph of logistics. In the Far East, the 14th Army used carriers in Burma, where Indian divisions found them vital for moving supplies through the jungle tracks. Even in the Pacific, Australian forces used them against the Japanese. Though the dense jungle limited their effectiveness compared to the open desert, one of the most spectacular uses of the carrier occurred. During the crossing of the Rhine in March 1945, the barrier of the river required amphibious capability, which the carrier lacked. The solution was the LVT Buffalo, a tracked amphibious transport. In a display of mechanical Russian nesting dolls, carriers were driven inside the buffaloes, ferried across the river under fire, and then disgorged on the German bank to immediately provide fire support. Simultaneously, massive Hamilcar gliders landed east of the Rhine, carrying carriers directly into the combat zone to support the airborne troops. This operation highlighted the ultimate flexibility of the design. It was light enough to fly, small enough to be carried by another vehicle, yet lethal enough to secure a bridgehead. The German resistance, crumbling under the weight of Allied material superiority, found themselves facing the very vehicle they had dismissed years earlier, now swarming across their borders in the thousands. The story of the Universal Carrier is also the story of the soldiers from dozens of nations who lived and died in them. Polish forces of the 1st Armored Division used them to close the Falaise Gap, holding the line at Mont Ormel against desperate German breakout attempts. The New Zealand Divisional Cavalry Regiment operated them from Greece to Trieste, using them for everything from reconnaissance to towing artillery. South African units pushed them up the spine of Italy. Even the Soviet Union received 2,560 carriers through Lend-Lease. Though they preferred their own heavy tanks and often relegated the lightly armored British vehicles to re-echelon duties, the most unique operator might be Israel. During the 1948 Arab-Israeli War, the nascent Israeli Defense Forces scavenged carriers from British scrapyards and captured others from Egyptian forces, using them to form their first mechanized units. These vehicles, some veterans of North Africa and Italy, fought on into the 1950s, a testament to the longevity of the Ford V8 and the simple steel hull. The post-war era did not see the immediate retirement of the carrier. The design was so sound that it remained in service through the 1950s and into the 1960s. British forces used them in the Korean War, where the mountainous terrain resembled Italy, and the carriers once again proved their worth in supplying hilltop positions that trucks could not reach. They saw service in the Malayan Emergency, patrolling rubber plantations against communist insurgents, and in Cyprus. The Irish Army, having purchased stocks during the war, kept them running for decades. The Swiss Army, always preparing for defense in difficult alpine terrain, bought American-made versions and kept them in reserve until the 1960s. It wasn't until the advent of the FE-432 armored personnel carrier that the British Army finally retired the Bren Carrier. The new vehicles offered full overhead protection and amphibious capability, but they lacked the raw, simple charm and the extremely low profile of their predecessor. In the final analysis, the Universal Carrier triumphed because it was the right vehicle for a total war of attrition. The German engineering mindset, obsessed with qualitative superiority, produced vehicles like the Tiger tank and the SDKFZ 251, technically impressive, but mechanically complex and difficult to master. The British engineering mindset, pragmatic and driven by the immediate threat of invasion, produced the Carrier. It was an acceptance of the reality that a good enough vehicle available in the thousands is infinitely better than a perfect vehicle available in the dozens. 113,000 units is a statistic that has its own gravity. It meant that whenever a Commonwealth soldier was in trouble, there was likely a carrier nearby to bring ammo, to lay down suppressing fire, or to carry him to safety. The captured German report of 1943 was technically correct. The carrier had limited armor, and was small, but it missed the point entirely. The tactical significance of the Universal Carrier wasn't in its individual specs, but in its ubiquity. It was the jeep with teeth, the mule of the mechanized army, and arguably the single most useful vehicle the British Empire ever produced.